Our first speaker is Nemanja Spasojevic, and he's from Clout, and he will be talking about when to post on social networks. Thank you.
Hi, everybody. First of all, thank you for having me here. My name is Nemanja Spasojevic, and today I'm going to talk about when to post on social networks. And this work has been done by a cloud data science team. So first of all, let me give you a little bit introduction, like what cloud actually is. Cloud is a social influence measurement tool. Users register on cloud.com. They can connect their social accounts, and then on the behalf of the users, we go and collect the users' data. And from the data, we derive like cloud score, users' expertise topics, interest topics, and then on top of this, we come up like with a recommendation of the content that user can share to maximize engagement with this audience. And in addition to this, we recommend also like what are the optimal times to share in order to gain the maximum reactions from the audience. So what's the motivation behind this work? Well, everybody wants to maximize their audience engagements. Like maybe if you're just the casual user, you want to get like most reactions from your friends, like likes, comments, favorites. Then if you're like a brand, you want to actually maximize ability to target your audience by posting at the right time. Or if you're, let's say, a brand which has like more strategic campaign and you want to post, let's say, like 10 pieces of content throughout the week, you basically want to know what are the most optimal times throughout the week to place those contents in order to get the maximum reactions. And then in past 2 to 3 years, there has been a lot of infographics recommending, hey, the best time is to post maybe on Tuesday after the lunch, or it's Sunday and Saturday. So what we are trying to do here, introduce the problem to the research community, open the data set, and propose the basic solution, but get a systematic approach to the problem rather than kind of anecdotal infographics research to say. So some of the challenges, like when analyzing the time series, usually it is like the data sparsity. So let's say even if you want to analyze the week in the 15-minute chunks, you will get about 700 buckets of the time, and for every single bucket to get some statistically significant statistics, like you will have to have a lot of data. So basically, for the research, one of the main obstacles is there is no open data sets. And then a lot of previous kind of anecdotal research was trying to alleviate the data sparsity by doing aggregates. So let's say like you aggregate something on the city level or the global population level. But when to post problem is a little bit harder because every single one of us has a unique audience, and the unique audience is composed out of people from different time zones, from different cities. So it's very hard to generalize these problems. And on top of this, every network has its own specific network dynamics. So it's very important to analyze every network separately. So basically the problem setting here is finding the best time when to post a message in order to increase the probability of receiving the reactions. And some of constraints we impose for the problem, we consider only replies, retweets, favorites, likes, and comments. That's what we can collect. And then we observe behavior, assuming the weekly behavior cycles. Then we make assumption that most of the reactions do happen within the first 24 hours. So we limit kind of optimizing problem for the first 24 hours. And then we look at the 15-minute buckets, where the first bucket is basically start of the week on the Monday relative to the user's time zone. And then just like quick system overview. So when user connects to cloud, like he authorizes cloud to collect the data on his behalf, plus we get the public data from Twitter GNIP stream. We collect all the data, parse it in generic form, and then from the collected data, we derive a creation profile. So basically that says when does user usually throughout the week creates the content. And then we also create like reaction profile, which tells you, hey, during the week, when does usually user react to the content. And on top of this, we build post-reaction profiles for each network separately. And then also we have basically user in graph and out graph, and in case of the Facebook, in and out graphs are basically the same. So we combine all these elements to derive first-degree schedules and second-degree schedules, and then we calculate the schedules and serve them on the cloud.com. So even if you go now, you can see your schedule, basically. So let's first gain a little bit insight about audience behavior before we dive into the personalized schedules. So post-reaction analysis. So basically, there is always inherent delay between like when you post something and when you get the reaction on the posted content. And different networks tend to have different dynamics. So for example, here on the x-axis, we plot on the log scale first 24 hours. And then on the y-axis, basically we plot fraction of reactions received given that total number of reactions is first 24-hour reactions. So we can see that for the Twitter, like 50% of first 24-hour reactions happen in 24 minutes. And then for other networks, it comes like, it takes 4 times longer to gain these reactions. So basically we use like this post-reaction analysis to anticipate amount of reactions one will receive over the time if he posts at the current moment. So let's look at some of the aggregate audience reaction behavior per network. So here we have the aggregate audience reactions for the New York specifically, and we observe it for Twitter and Facebook. We can see that for Twitter, the peaks are much more pronounced, while Facebook reactions tend to be pretty continuous throughout the day. And then both Facebook and Twitter kind of, there is more reactions going on like throughout the work week, and then on the weekends people kind of tend to be a bit less on the social networks. In addition to this, on the bottom graph, we look at the similarity of and correlation of audience reaction behaviors for the same user across these two different networks. So we can see that for a given user, correlation between like Facebook and Twitter, actually it's always positive, but it can vary widely. And similarly, the similarity peaks about 0.7, so it is like relatively high, but still you cannot kind of try to generalize one personalized schedule that is going to work for both Twitter and Facebook, just because like the audience react differently on different networks. And finally, let's look at some of the location behavior. So what we do here is for the users within some of the major cities, we aggregate their reaction behavior within the city. And we can see that actually the US cities tend to kind of have similar shapes, like San Francisco in red and New York in green, although like San Francisco tend to wake up about like 1 hour earlier, and then other cities tend to have a little bit different behavior. So for example, peak of reaction is maybe moved after the working hours compared to US, where most of the reactions happen earlier in the working day. So basically even here we can see that audience reaction behavior varies widely depending from the location to location. So it would be very hard to generalize for one city and make sure like that schedule applies for another. And let's look into the personalized schedules. So we do derive like two types of schedules. One we call like a first degree schedule, and there we basically take in consideration when does the user create the post, and then when does each of his audience members usually react to the posts. And in the second degree, we kind of try to make it a little bit more sophisticated, taking into consideration for a given audience member, like what's kind of load on him, like what is he seeing except your post. So for example, on the Twitter, if you're following a lot of people and you're having a whole bunch of incoming tweets, maybe you're not going to be able actually to see the broadcasted tweet from the user just because the audience member is getting overwhelmed. And we build these schedules in two flavors. One is where each audience member is basically equally weighted, and one is like where we weight audience members in respect of how much in the past given audience member was engaging with the author that is sharing the post. So here, for example, we show like the weekly schedules. So in the red line, it's first degree weighted. In the blue line is the second degree weighted. And then the green broken line shows just the aggregate reactions of the audience for a given user. And in the purple line, like we actually show like the post to the reaction filter, which is, and there we can see that actually reactions drop out pretty quickly as a function of time when the user pauses. So observing like first 24 hours, it's perfectly fine for all the practical reasons. And so we do evaluate these personalized schedules. For the evaluation, we use like 56 days of unseen data. It includes about 500,000 of active users. And the metrics we use is average reaction gain, where reaction gain we define as the ratio of reactions per message in a bucket over the reactions per message across all the buckets. So basically, if you have like a 15-minute bucket, like how much better it's performing than the average behavior of the user. And then we compare with two baselines. One is the most frequently used, which is basically when do usually people post in a given time zone. And the second one is aggregate first degree, which is basically aggregate for a given time zone when do usually people react to the posts. And then on the graphs, we can see that basically the first degree weighted personalized schedules perform the best. Like we can get about 70% gain on the Facebook, 4% gain on the Twitter compared to the others. And we can look at the baselines, don't perform much better than just the regular user behavior. And that's it. So one of the main contributions of this work actually is opening the data sets to the research community. We anonymize post-reaction timestamps together with anonymized user IDs, which are fingerprinted, and they do match across the network. So for example, same user ID fingerprint is going to be matching across Twitter and Facebook if it's the same person. And then we slightly perturb timestamps just to ensure like a perfect anonymity. And then like if you're interested, you can check it out on the GitHub. And the data set includes about 1.1 billion reactions. So hopefully you get some use out of it. So finally, we saw that the Twitter is much faster than the other networks. Like reactions happen about 4 times faster than on Facebook. The audience behavior can vary like wildly across the different networks. Also, the audience behavior patterns vary highly across different cities. And then we saw that using personalized schedules, we can see like gain of the reactions of about 17% for the Facebook, 4% for the Twitter. And we hope that open data set can benefit the research community. And that's about it.
All right, we have time for a couple questions.
Did you, in your problem, consider the user verbosity as an effect of the as an effect that it has on the audience? For example, if a user or a group is very verbose in tweeting or posting, then they may not they don't get as much reaction as they should.
Yeah. So basically, the problem was limited, just like for if you have a chance to share like a one post, like what would be the reaction gain? But you're right, like that could be like the future improvements.
Hi. Is there place on the schedule for exploration, active exploration, that suggests a user, can you post something on Monday at midday because we don't have data for this particular moment or something like that?
Can you repeat the question?
So if you are proposing a schedule for the person to post, but I can imagine that's trained on data where in the moments where the user is likely to post anyway. So if I never post at midday on Mondays, you probably don't have data to train on that. So is there any work on active exploration on when to post?
So basically, we make a suggestion for you when to post, but then like if somebody from your audience like was reacting, then we make a suggestion based on that.
Okay. The question is where it was some kind of exploration also in there, or is... So do you suggest people to actively explorate when to post, or is always based on their previous...
It's always based on the 90-day trailing window, yeah.
Okay.
Well, thanks.
When I look at the graphs by city, it seems like there are some really very different patterns that suggest, perhaps, for example, in Japan, that people are using these networks more socially because they go from very late, they go until very late and also start early, whereas in San Francisco it's more peaked maybe during working hours or something. Yeah. Is there any sense, or perhaps, I know you haven't released the content, but whether there are sort of different use cases that have different reaction patterns that you might be able to distinguish?
Yeah, so it's a pretty interesting problem. Like, we didn't dig too much deeper into it. We did some validation. For example, I think there was some previous research saying like San Francisco does wake up earlier than New York. And then for Japan, it's interesting. I don't know if there is like a different work policy. Like, for example, if you can use like a Facebook at work and then you're basically forced to kind of pick off working hours compared to the US where people are kind of just after lunch going and checking out their Twitter or Facebook. And then in the commute hours, it's interesting to see also, like for example, for Twitter, basically there is a secondary peak when people are commuting. They kind of probably just check the Twitter.
Okay, I think we have time for maybe one more.
So if I were Facebook or Twitter, if I were building a product that's recommending people when they should be posting, and if I have real-time data and I know like who in your network is actually online at that time, like why wouldn't I just use like the number of people who are in your network who is online and the peak time to actually recommend you to post at the time?
Yeah, so if you're Facebook or Twitter, you probably have much more access to the data, right? You have like access to when do people view, when do people are online and stuff like that. So sure, you could build a much better product just given that you have access to much more data. But it's true, yeah.
Okay, and let's thank the speaker again.